Okay, so our first question is dividing a line segment into 4 equal segments. Well, we know we can break it into 2 equal segments called bisecting. So if I bisect the bisector, that's fine. So we'll start off with bisecting this segment. I'll do this in red so we can see the differences. And then I come to this side, same measurement. Okay, I connect my points. And there we go. So this is the midpoint. So it bisects, these 2 segments are now the same. And then I'll bisect those. So I'll set up again. And over to the midpoint. Oh, staple got in the way. And I'll bisect there. So now I've got 2 smaller segments. I have this segment and that segment. And I'll do the same on the other side. So again. So just remember that a bisector is going to break things into 2 equal parts. And if I want to break into 4 equal parts, I have to do more than one bisector. And there we go. 4 equal sections. 1, 2, 3, 4. Okay. So let's take a look at the next one. Still working with perpendicular bisectors, but I want to bisect all 3 sides. So I'm going to do this in 3 separate colors so you can see it pretty clearly. So bisecting this side. Coming over to this side now, same measurement. Oh, I'm going to get in the way of the camera here for a brief moment. Okay. And bisect that side. Now I'm going to make this line pretty long. Okay. Now let's do another side. Let's do the side over here. So I'll use the other endpoints of that side. Keep same measurement, different measurement, doesn't matter. I just want to make sure I keep the same measurement on both sides here. Ooh, you know what? Look at what happened here. I didn't really get big enough apart. So I got to redo that one. Okay. Be prepared for things like that. If you don't make your measurements big enough, you got to do it again. So I'm going to do it again. Ah, that's better. Now I've got 2 points that I can connect. Okay. So I can connect those 2 points. And then one more. So the bottom here. We could call that the base of our triangle if we wanted to. Hopefully that stays on the paper. Whoops, losing my paper. And I'll connect those points. And notice all 3 of those pretty closely came together at one point right there. Okay, that's what they're looking for. This point of intersection is equidistant from each of the vertices. So I can circumscribe. Circum means around, scribe means draw. I'm going to draw a circle around this triangle. So I'm going to center at that point. I'm going to set up here. And if I did this perfectly accurately, this circle should hit every vertex. Chances are I didn't do it perfectly accurately because these are not great compasses. But you can see I got really close to hitting every vertex. Okay. Now, we're going to talk about this tomorrow about what this point is called, but this point of concurrency is called the circumcenter. And we'll talk about that tomorrow. Okay, let's look at another.